welcome to E-Pathshala lecture series on computer science, and this course we will learn about operating systems, and in this course we will learn about how operating systems were designed and what are the different modules in operating systems, the functionalities of each, the algorithms involved in the different modules and so on. And in today's lecture, we will learn about what an operating system is, we will understand and we will learn the different definitions of operating systems, and we will also look at the different features of different operating systems that had evolved over time. So, right from when operating systems came into existence, the operating systems had evolved and different functionalities had been added to operating systems. So, we learn about the different types of operating systems, and we will also see what will be the future of operating systems depending on how situations have been changing. So, we will first learn about what an operating system is. So, what is an operating system? It is actually a software. So, this software is a part of any computer that is present, and this will actually act as an interface between the user who is using the computer and the hardware that is present in the computer. So, for users to easily use a computer, this operating system paves way. We cannot really know what is happening inside and how the hardware is actually working. So, we need to have someone who sits in between the user and the hardware, or the application programs that are run by the user and the hardware. So, this operating system will also manage the different resources for different users' applications. Say for example, you have a number of resources in the computer, like you have the CPU, you have I/O devices, you have the memory, etc. and so on. And these resources have to be utilized properly between different applications that are running in the computer. So, it is not necessary that you will have one application running. You will have, or you may have, a number of applications that are running, and all these applications may have to use different resources. So, this operating system is in charge of managing the resources or properly allocating the different resources among the different applications. So, if you look at the goals of any operating system, it will help to execute the user's programs, and it will help to solve the user's programs in an easier way. When an operating system is being designed, so what is the criterion that is being looked at for the design of the operating system? Say for example, we use the Windows operating system and we have a GUI which is easier for the users to use. So, convenience is an important issue that had also been looked at when this operating system was designed. And if you look at the earlier Unix systems, efficiency was the main reason or the main concern for while the operating system was designed then. In those days, they say many users could or were able to use Unix systems at the same time, but really not much of GUI were developed. But these days even Unix systems can have a good GUI, have good GUI, which is easier and convenient for people to use. So, it again depends on for what kind of application the system is being used. Based on the type of application, whether the convenience or the efficiency is taken into consideration during the design of the operating system. Now, if you look at the different definitions given for operating systems can be looked at as a resource allocator. As I told you earlier, you have a number of resources that are present, and the operating system looks at managing the resources and allocating the resources for different people, and it also acts like a control program, that is, it will control the execution of user programs and operations of IO devices. And there is one definition that says that this operating system is the one program that is running at all times in the computer, that is, and it is called a kernel. Okay. So, everything else that is running in the machine is either a system program or it is an application program. When you say it is a system program, it is a program that comes along with the operating system, but it is not the operating system, but it is used for some other system related jobs. So, having seen these definitions of operating systems, we will now move on to see how operating systems had evolved over time. So, initially when machines came into existence, that is when computers came into existence, they were really mainframe systems. That is, the early computers were large in size, maybe occupying one big full floor in a building, and they were very expensive, and though being big in size, it could be used only by a single person. So, the users are supposed to take their programs in cards and give them or feed them as input to the computers, and the processing will be done in the mainframe systems, and the output can be got by the user probably only the next day. So, users will go one after the other, give the input, and they will have to wait for the next day till the next day to get back the results. And if you look at these systems were called as mainframe systems, and if you look at these systems, you have jobs that is coming one after the other. There is no jobs that will be working parallelly, but the system only had to look at transferring the control of the job from one job to another in a sequential manner. And what the system can do is that maybe it can reduce the setup time by batching jobs together. If the jobs are similar, the jobs can be batched together. So, these kind of systems have very limited operating system functionalities. So, there will be a resident monitor, there will be an OS that resides in the system, and initially the control will be in the monitor, and then the job the control will be transferred to the job. When the job completes, then again the control will be transferred to the monitor, and so on. And if you look at this, it is only processing of jobs one after the other, and hence the CPU will often be idle, it will not be used always, and hence later they brought in something called the disk technology. So, in early mainframe systems, there was nothing like disks, or there was no disk, but only machines existed and some processing had happened one after the other. So, you look at this diagram, you can see that you have an operating system, you have a single user's program area. So, where a particular user's program will be put in, and only that program will be executed. So, when disks were introduced, the jobs could be put into a disk rather than the jobs being produced as input from a serial card reader. It is being put into the disk, and hence you can have multiple jobs being put in a disk. So, this multi-programmed batch systems came into existence. That is, now you have disk, and hence several jobs are kept in the disk, and because of that it is possible to bring in several jobs into the main memory from the disk at the same time. And now you have several jobs in the disk, and hence we need to, or the operating system has to do one additional work, that is, it needs to decide on which job of all these that are present in the main memory can be given the CPU, because at a particular time it is a single processor, the CPU can run only one program, or only one program can use the CPU. So, when there are multiple jobs in the main memory, one of these jobs should be selected and be given the CPU. So, this kind of functionality had to be added to the operating system, and in this case the CPU is never idle, because one after the other some job will be assigned to the CPU. Say one process is using, or one program is using the CPU, and then if it does not want to use a CPU, if it wants to wait for something else to happen, then the next job can be given the CPU. And another thing here is that you have disk and multiple jobs are placed in the disk. So, one of the jobs that are present in the disk should be brought to the main memory, or say if you can keep say 3 programs in the main memory and there are 10 jobs in the disk. So, out of these 10 programs in the disk, you have to bring 3 into the main memory. So, these 3 programs that are brought into the main memory should be decided by someone. So, which 3 should be brought to the main memory? So, that will be decided by someone called the job scheduler. So, this job scheduling was another feature that was added to the operating system. And the third feature that came in was memory management. That is, I told you that there are 10 jobs in the disk. You bring in 3 jobs into the main memory, and these 3 jobs, where will you place these 3 jobs in the main memory? So, that has to be decided, or the main memory space has to be allocated to several jobs or to these 3 jobs. How do you allocate? You need to have some feature of the operating system doing this, and that is called memory management. And then among these 3 jobs, one should be given the CPU. Which one will be given the CPU? That should be done by someone or some part of the OS, and that is CPU scheduling. And then I/O has to happen. Say any program may have to do some printing or may have to take some input from the user and so on. For that, I/O needs to happen, and the I/O also had to be taken care of by the operating system. And when there are multiple devices, allocation of the devices also have to be taken by the operating system. So, new features were being added to the operating systems when multi-programmed or multi-programming was brought into computers. And here in multi-programming, you have multiple programs that can be kept in the memory, but actually there is no actual interaction between the users and the computer. So, users, different programs can be placed in the memory, but the one-to-one corresponds, a one-to-one interaction between the user and the computer was missing. So, for that they wanted to bring in some interactiveness. So, they brought this kind of system called as time sharing systems. So, this is basically a logical slight extension of multi-programming. These systems are also called as multitasking systems, and in the systems also you can have multiple programs that are present in the that are kept in the memory also, and many users can use the system at a particular time. Say for example, you can have one machine in which all users programs run, and terminals can be given for different users, and all users programs can be run in that one machine. So, the CPU here can run multiple processes from different users, and hence each user will have a feeling that he is using the entire CPU for all the time. So, that is because the CPU is much faster compared to users, and hence such a kind of effect happens. So, here CPU scheduling will be there, job scheduling will be there, because jobs will be placed in disk and you need to bring them into memory. There are many programs in the memory and only one can be used by the CPU, and all these will ensure that the speed with which, or the interactive speed will be much higher for the users. And in this kind of system, many users can use the computer. It's not that it's not a single user communicating with the computer, many users at the same time they can use the computer. And very similar to how you have for the earlier multi-program systems, you also have memory management, because many programs can be present in the main memory at a particular time. And here we say currently only 3 programs can be placed in a main memory say, and there are say around 20 users who are using the system. So, all the 20 users programs will be present in the disk, and only 3 will be present in the main memory, and one of these 3 will be using the CPU. And but we need to have we need to give a feel to the users that they are using the system continuously. So, what is done? See the 20 programs in the disk, and of the 23 in the main memory, one of which will use the CPU, and say this program that is currently using the CPU is partially done and it needs some input. So, it has to wait for some time. So, that will be put to the secondary storage device or put to the disk, and some other process will be brought into the main memory. So, this brought in the concept of virtual memory, okay. And it is also possible that a program which is much larger than the size of the physical memory can be executed, because at a particular time, even in a big large program, only one small or only one instruction is going to be executed at a particular time. So, only that portion of the big program need to be present in the main memory, not the entire program. So, this helped in this, or this brought forth the concept of virtual memory, and file systems came into existence, because files have to be placed in the secondary storage device. Many users are using, and hence many users will have their own files, and hence all these files have to be ordered in a proper logical manner. So, file systems came into existence, and when file systems came into existence, we also had to bring in disk management, how disks are managed, and then other is concurrent execution. It may be possible for 2 programs to execute concurrently, in the sense 2 programs of 2 different users may be executing concurrently, like one process being using the CPU, and after some time say the other process will be given the CPU, and maybe the first process will be given the CPU later, etc., and so on. Or there can be a switch between different programs or processes, so that both the users are feeling that their program is running, and hence it is possible to have concurrent execution. And when you have this kind of concurrent execution, and if the 2 programs of both the users are using some common resource, there needs to be some synchronization between the 2 programs for the proper use of the resource. And there may be a possibility, or there can be a possibility, that even these 2 programs of 2 different users are communicating among themselves. So, all these had to be taken care of by the operating system. And when 2 users programs are communicating among themselves, when 2 users programs are trying to access a common resource, there is quite a lot of possibility that they can get into a deadlock. So, deadlocks handling was also a part of the operating system. So, a lot of features were brought in when time sharing systems came into existence. And then came desktop systems, basically having personal computers. So, each user using his own computer or owning his own computer. Earlier, different users were able to use a particular computer in time sharing systems. Here, each user has his own computer. So, here you do not need to have multitasking or multi-user capabilities are not needed. You can have I/O devices like keyboards, mice, display screens and printers, etc., and so on. So, basically this was focusing on the operating systems were focusing on the convenience of the user and the responsiveness that have been given to the user. So, the individuals have sole use of the computer, and hence advanced CPU utilization or protection features are not needed. There may not be a big problem of security because only one person is going to use his own computer. But the thing is that current days even these PCs or desktop systems are being connected via network to many other computers around the world, and hence even in desktop systems or PCs, security measures had to be brought in later even in desktop systems. So, OS operating systems had to bring in security even in desktop systems. So, there are different types of operating systems that can run on desktop systems, as you all know, Mac OS, Windows, Linux, Unix, etc. and so on. So, till now what the different operating systems that we were seeing had only one processor. There was only one processor in a particular machine. Now, we are looking at multiprocessor system. Actually, there are machines with one processor only, but they all work together, or there is a possibility of different machines with different processors to communicate among themselves, and hence they can all work together to provide better performance. And this kind of systems are called tightly coupled systems. In tightly coupled systems, the different machines or the processors in different machines, the processors can share a computer bus, they can share a memory and also a clock, and communication is taking place only through shared memory. So, what we have seen till now is that processors being only one in each machine, that is in each machine there is only one processor. But now we can have machines with multiple processors, that is machines with more than one CPU in them, and these CPUs or processors will communicate among themselves. That is, this is called a tightly coupled system, where the processors will share the computer bus, the memory and the clock, and generally communication is through shared memory. So, if you look at this, if you look at advantages of these kind of systems is that there is increased throughput. Rather than one processor working, you can have some n number of processors that are working together, and hence the throughput is high. And it is economical in the sense there are multiple processors which can run multiple programs, but they can all share the same I/O device. Say for example, they can share a printer because I/O is slow. So, they can share a printer and they can even share memory and other resources. So, its advantages. The other is having increased reliability, that is, say even if one of the processors fails, all the other processors can be used and the other process will take over. So, there is no actually 100% failure that will happens here, and hence the system is reliable. In this kind of systems, you can have either symmetric multiprocessing or asymmetric multiprocessing. In symmetric multiprocessing, all processors are peers, or all processors are similar, and each processor will have the similar or an identical copy of the operating system, and hence many processes can run, and there is less performance deterioration, or you can say that there is no performance deterioration, and most of the modern operating system supports this kind of SMPs. Or you can have an asymmetric multiprocessing, where each processor need not be a peer. There can be one processor called a master processor, and the other processors are called slave processors. So, this master processor is in charge of allocating the different programs that are coming to the different slave processors, and you can even have different processors with different capabilities, and each can do their own kind of job. So, this kind of systems are called multiprocessor systems or parallel systems. Now, we have something called distributed systems, that is, you have different machines which are connected by a network, and processing can happen in all these different machines, and these systems are called loosely coupled systems. So, there will be one machine or one processor with its own local memory, and different processes or different machines can communicate between themselves using communication lines, using high speed buzzers or using telephone lines, etc., and so on. And here again the advantages are that you can have resource sharing, because resources that are present in different places but connected to a communication network can be shared between different machines or different processes. And there is a computational speed up, because one program can be divided into sub programs and can be given to different machines or different processors, and they can be executed in parallel, and hence there is a speed up in computation, and you have a load sharing that happens here. Again reliability, because even if one of the machines fail, the others will take over, and hence there is reliability. And this kind of distributed systems need networking infrastructure, and this can happen either through LANs, local area networks, or through wide area networks. And these distributed systems again can be client server kind of systems or peer to peer systems. In client server kind of systems, there will be one server and multiple clients. So, the server can have different capabilities, like it can be a compute server or it can be a file server, and the server will provide service for the different clients. Or you can have peer to peer systems where different peers can work together and execute programs. And when you are looking at this kind of distributed systems, operating systems need to have networking, some facilities that needs to support networking. That is, it needs to provide features such as file sharing over the network. There needs to be some features that will ensure or enable communication between different processes over the network. And now then we have this real time systems. Real time systems actually will be used in machines where real time programs run, and this can be classified as two, that is soft real time systems and hard real time systems. So, basically in real time systems you will have some time constraints for the application programs that are running, and in hard real time systems the time constraints are very rigid. That is, if something has to happen at a particular time, it has to happen at that particular time, it has to get over at that particular time, and critical tasks are running or will be running in this kind of systems. So, if you look at this kind of hard real time systems, the operating system will be specific and will be devised only for that kind of application which should run on that system, and there will be no secondary memory or secondary storage present. You will have only a short term memory or read only memory, no virtual memory is allowed, and this kind of systems cannot run with the other time sharing systems because time is very rigid. And you can also have soft real time systems in which the time constraint is not very rigid. That is, a real time task will also run with other tasks in the system, but real time tasks will get a higher priority than other tasks, and hence this has got limited utility in industrial control of robotics. It has got also applications in multimedia, virtual reality, and so on. And then come our handheld systems. So, these days we have got a number of handheld devices like cellular mobile phones, PDAs, tabs, etc., and so on. If you look at these devices, the issues are that they are limited in size, very small in size, the memory is limited, and they have slow processors, because if the processors are very fast, then you need to have a lot of power backup to be given, and the display screens are very small. So, web pages cannot be displayed as such on the screens of these devices. So, some kind of web clipping has to be done. So, the operating systems that are devised for these handheld systems, examples are iOS, Android, Symbian, etc., and so on, and it needs to support or needs to take into issues of all these like limited size, less power, battery problem, etc., and so on, and it is only needed to support for single user. We do not really work with multi users, and but the thing is that the OS will have to give support for the varied types of applications that have been developed for this kind of devices. And the other is, these devices use the internet and download lot of things, and hence security should also be considered for operating systems to be used in these kind of devices. And then we have embedded systems. We have a number of devices these days, number of machines these days like microwave ovens, cars, medical devices, etc., and so on, where some software keeps running and there needs to be some customized operating system which is specific to that particular task or specific for that particular device being put into that device. So, such operating system have to be developed very very cautiously. Say for example, if in some medical device you are putting in an operating system and if there is some programming error, then that can cause a devastating effect. So, future of operating systems, what you have seen till now is different kinds of operating systems that are available. In future, the future of operating systems is also dependent on the future of hardware, and based on the future of hardware, operating systems should also be designed accordingly. So, when there are data centers or multi-core systems or ubiquitous portable devices or heterogeneous systems, whatever be the case, operating systems have to be devised accordingly. So, with this I conclude this topic. So, what we have learned today is that we learned about what operating system is, what is the definitions of operating system and the different types of operating systems, how they evolved and how the future of operating systems is going to be. Thank you.